Let's talk about data distributions. A data distribution is a graph that shows how frequently data values occur. There are many types of graphs that show a data distribution. One that we'll look at is a dot plot. A dot plot is a data distribution that's used with simple or smaller data sets for up to about 20 values. A histogram is another type of data distribution graph that's used with larger data sets. Let's read a dot plot together. This dot plot represents the answers to the question, how many siblings do you have? Each dot in the dot plot represents a response. So if we count up the number of dots in our dot plot, then we'll know how many people responded to the question. So in the first column we have 1, 2, 3, 4 dots. We have 8 dots in the next column. And then we have 6 dots, and then we have 3 dots, and then we have 1 more. If we count all of those up, that's a total of 22 dots, which means that 22 people responded to the question. If we write out the list of data, then it should have 22 elements in it. So I'm not going to write the whole list, but we'll get started. We know we need 4 zeros because 4 people responded that they did not have any siblings. We would follow that with 8 ones, and I'm not going to write them all. I'm just going to put the dots because I think you get the idea. We would have 6 2s in our list. We would have 3 3s, so I'm just going to pick up right there. And then the last thing in our list would be 1 4. Next, we want to find the mean number of siblings. Remember, mean means average. So I need to add up all of the values in my data list and then divide by how many elements I have. So I know that I have 4 zeros, so I'm going to use multiplication here. 4 times 0, and then I have 8 times 1, which is 8, and then I have 6 times 2, and I have 3 times 3, and I have 1 times 4. So if I add 0 plus 8 plus 12 plus 9 plus 4, then I get a total of 33. And then I want to divide by the total number of elements, or the total number of answers, which is 22. And when I simplify that fraction, I get 1.5. To find the median number of siblings, remember that the median is the middle. And to find the middle, I need my data to be in order, which it is on our plot. And then I need to find the middle number. If there are 2 middle numbers, then I have to average those numbers together. Since we have 22 items in our list, that means we have 11 items on one side of the middle and 11 items on the other side of the middle. So I'm going to count from the left, remembering that my dot plot builds from the bottom up, and I'm going to count 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's my 11th item. And so the one right next to it would be the 12th item, and I'm going to have to add those together. The value of each of those is 1. So I need to add 1 plus 1, and then divide by 2 to find that average. 1 plus 1 is 2, and 2 divided by 2 is equal to 1. So my median number of siblings is 1. The average is 1.5. Next, let's look at 3 types of distributions. We have a normal distribution. We might have one that's skewed right, or we might have one that's skewed left. Think about taking your distribution graph and laying a blanket over it. So the curve represents a blanket that's on top of our distribution, and if we see some symmetry, if most of our data is right in the middle, remember that would be our mode, our median and our mean are going to be equal, and they're also going to be right in the middle. We call this a symmetric distribution because if we fold it on the midline, then it's going to fold right on itself. One side, the side on the left, looks exactly like the right side. And it's important to point out that the mean and the median are equal to each other when we have a normal distribution. Now picture that blanket on your distribution or on top of your data, and you're on the right side of it, and you're pulling the blanket to the right. If you're pulling that blanket to the right, then you're pulling that data with it, and we say that that's skewed right. This is the direction that is to the right. And so we see that we have a tail on our graph that's longer on the right than it is on the left. That tells us that the distribution is skewed right. Look what happens. Most of our data is right here, and that would be our mode because the mode is the most. The median is pulled a little bit to the right, but the mean is pulled a lot more to the right. When we have a distribution that's skewed right, the median will be less than the mean. If you have a blanket on your data and you pull it to the left, then you're going to skew your data to the left. You have this tail that's longer on the left side than it is on the right side. So everything is being pulled to the left. So most of our data is going to be over here. So our mode is here. The median is a little bit left of the mode, but the mean is a lot further to the left when our distribution is skewed left. So if our tail is longer on the left side, then that means that our mean is being pulled to the left, which means that the mean is less than the median. These are the comparisons that we want to make in this lesson between mean and median. So for skewed data, either skewed right or skewed left, it's better to use the median rather than the mean to describe the center of the data, because the median doesn't move as far away from the center of the data when it's skewed. If we go back to our dot plot and put a blanket over our data, then it would look something like this. And you can see that the tail on the right side is a lot longer than the tail on the left side. So we would say that this is skewed to the right. It's skewed in the direction where the longer tail is. Since it's skewed to the right, we expect that our median is going to be less than the mean, because the mean is being pulled to the right. The mean is being pulled this way. And you can see that our mean is greater than our median when we found those exactly. But if we have a distribution that's skewed right, the median is always going to be less than the mean, which means the mean is greater than the median. On the next page, let's look at some scenarios given to us in different representations and determine whether the distributions are more likely to be skewed to the left, to the right, or if they're symmetrical. So if we think about the age of death in a city, most people die when they're older. So if we have young people on this end and we have old people over here, then our data, we don't know exactly what it is, but our data we know is going to mostly fall in the old part. So maybe our distribution will look something like this. If our distribution looks like that, then that means the longer tail is on the left, which means that it's skewed to the left. What that means in terms of our median and our mode is that our mean is going to be pulled to the left and it's going to be less than the median. Think about the foot size of a 30-year-old woman. If I had a whole big group of 30-year-old women and I looked at their foot size, then most of the sizes would be about the same. There would be some people who had really tiny feet, and there would be some people who had really big feet, but most of them would fall somewhere in the middle. So in that case, we would expect to see a distribution that looked like this. Most of the data would be in the middle, and we would say that that is symmetric. If we have a symmetric distribution, then that means that the mean and the median are just about equal to each other. On number 3, we have a data distribution graph given to us. It's a dot plot. So we want to lay a blanket on this, and it would look something like this. Remember, when you lay a blanket on it, it doesn't catch all of the dips. You're just getting the general idea of where the data is. Since we have a long tail over here on the right, we would say that this is skewed right. If it's skewed right, then it's pulling the mean to the right, which means that the median, which stays closer to the middle, is going to be less than the mean. Look at the histogram on number 4. Again, let's lay a blanket on that, and it would look like this. Since we have this long tail on the left, we would say that this is skewed left. Since it's skewed left, the mean is going to be pulled to the left, and if the mean is pulled to the left, then that makes it less than the median, which stays closer to most of the data. Another type of data distribution graph is a stem plot, or sometimes called a stem and leaf plot. The stem represents a value that's repeated, and the leaf represents each data point. There always has to be a key to the stem and leaf plot that tells you how to read it. So in this case, on number 5, the key says 3 with a /1 represents 31 years old. So if I read this first line right here and just write the data points, it would be 15 would be one value, 15 again, and then 16. Then I would continue my list with the second row, which would be 20 and 23 and 23 and so forth. Our data distribution on a stem and leaf plot is sideways, so we have to tilt our head to the right, and if the smaller numbers are on the top, then we can read our data distribution this way, and we can see that we have a longer tail to the right. Remember, your head is tilted, and all the data is being pulled to the right. When it's skewed to the right, the mean is pulled to the right, which makes the median less than the mean. On number 6, our stem plot represents the length of worms that have been caught, and then they measured them. So we have a worm that's 3.0, that's the smallest, 3.5 is the next one, and it goes all the way up to 10.0 centimeters, and there were 3 that had that length. If we lay our blanket on this, again, tilting our head to the right to read this, then we can see that the longer tail is on the left, which means that this is skewed to the left. When it's skewed to the left, the mean is pulled to the left, and it becomes less than the median. So let's define outlier again. An outlier is a data value that's much bigger or much smaller than the other values. So it's not close to most of the values at all. And we want to know, what effect does this have on the mean, the median, and the standard deviation? Think about that and write your answers, and then come back and check. An outlier is going to cause the data distribution to be skewed to the right or to the left, and we know that that skew changes the mean. It pulls it in the direction of the outlier. So the mean will change if there's an outlier, and it will be pulled in the direction of that outlier. The median is just the middle of your data. So if we have one data point or 2 data points that are outliers, then they're not going to change the median very much. The median is going to stay very close to the middle. And then the standard deviation always increases when you have an outlier, because the standard deviation tells you how far apart the data is. Be sure that you complete your practice and check your answers before you try the mastery check. Good luck!